Alright. Hi, good afternoon students. Can you hear me? Alright, excellent. Alright, so look like everybody staying home for carnival. We'll see how it goes, right? So this will be a short lab, hopefully. As we have nobody else in person yet. We'll see how it goes, which means if nobody else is here, there's no break. We're going straight through. See, that's why I record the screen too. Smiley on candid camera, right? Please don't walk through my lab when I'm doing this. Walk around the class, please. All right. Okay, so I put up the stream link, so you guys could go ahead and click on that. The Zoom session today is recording, I think, yes. All right, so first things first, the PDF I uploaded had BGP configuration as next week's, well, won't be next week's lab, it'll be the lab after that, because Carnival Monday is, well, not a public holiday, but I already scheduled not to have any labs during that day. All right, so BGP will be done the week after. So what happened was a mix up of the lab. What I ended up doing was following the procedure online. There's a procedure that you follow online, IT exams. I also uploaded the PDF for that procedure, so that's what ended up happening. So what you can do is follow that. So those who have followed this lab before and tried it before, you will notice that there's BGP and not HSRP. Maybe, and you could ask questions, but judging by nobody asked any questions, I'm going to say nobody attempted it before until now. Right, so that's 1, 2. I deleted the old lab and put in the PDF, so those who have just checked it, you might have downloaded the old one, and now you're going to, if you refresh my learning, you're going to see this has been removed. I put the new one. Right, so this PowerPoint here. All right, so let's start. Right, we packages a file is what we're focusing on. Double click normal thing, double click to open, make sure you log into your NetAccount account, open the page and follow the steps on this website. So I'm going to click on this. It should fire up browser, Chrome or otherwise. Right, so I'm actually following this. I download this page as well as a PDF just in case this page is taken down or changed up, or it's download as well, right? So this is what so this is the purpose of this lab is something called hotspot redundancy protocol. Now it's a WAN, more or less used in WAN technologies, but it can be used in LAN technologies as well. Now earlier today, I actually just had a nice little idea. There's an image from Ubiquiti website which talks about redundancy and setting up. Because it's a WAN course, not really LAN, I will have you try to put some redundancy setup in there. So I'm going to see how I could take that screenshot. So they have a nice little diagram, nice little video showing you how redundancy works with multiple internet sources, multiple gateways, multiple switches, and multiple wireless access points. So this was designed that you could end up having a failure all the way down one side and your redundancy will continue working, or you can have a mixed match of failures along the way in the structure. I would not, yeah, maybe we have time, right? Let me just put it up in Ubiquiti and I'll give you an example. Let me see if I can get this up. Lovely. Right. Why use Ubiquiti? Because I find it's pretty good. Price point is so good, but this is actually pretty good in terms of coverage. There's a bigger model E7 campus, which is meant for like universities and stuff. which is $7.99. So guess look what they're doing here. They're demonstrating a WAN layer, right? So you see what's happening here? You have two internet sources, and they actually have a WAN device here that's load balancing. The cool thing about this is that if one switch, look at that, one switch failure, look at this, it's showing gateway failure, aggregation switch, and you see where they're doing it? The failure is actually just back and forth. But that's fine. This a whole section, the left hand side can be, look at this, ISP failure. So this is where HSRP comes in at that point. Where does HSRP comes in? You see this between the gateway layer. That's where most likely where it is. Between the WAN layer and gateway layer is where our HSRP is actually going to be happening. Alright, so this is a nice animation demonstrating this. So what I might want to do is I might take this piece and stick that in the group project. Everybody's going to do something like this. You're going to use HSRP, you're going to simulate ISP failure. You're going to simulate where you have two ISPs going out to your plan, and you're going to do your WAN links, the gateway layers, and all this is the back end of your enterprise. So right, so this is not the internet piece, this is your enterprise connection to the internet. Right, so you're going to build out some redundancy in place. This would have been good for LAN as well, but because we're doing HSRP, it was in LAN, but we're going to just jump, we'll do some other bit of LAN stuff in here. Door, we could look at not the gateway, see the core layer here, the access layer. This is where we could do some forum stuff. You guys can know the commands, so you can have some discussion on this. So you can do it on your own. And then you have the access points. You'll notice one thing here. Each access point here has two links, each to a separate switch. That is design, which means a switch could fail, and they showed it there. A switch fails and one link still continues, you still have network access. So this is what I think everybody should strive for in any organization. Try to get this level of redundancy. Now this is the kicker. All of this could be on one site. But what is better is if you could get all of this separated onto two sites. Or not separated, duplicated onto two sites. So you can actually have an entire site failure and you can still have connectivity going out. That gets a little more complicated, but the cool thing is that you're going to have that level of resilience and redundancy. And when I mean replicated, I mean you're going to have two WAN switches on one site, and each of that site is connected to two ISPs. That's what we have. And the second site, you're going to also have two WAN switches, and each of them are connected to those two same ISPs. And then it's coming down, it's training down, and then it's going to come back to a point where they have the switches. Now you're going to balance this. It's going to end up having 4 switches in all, and only 2 access points. So what you're going to do, you got to balance it out. One switch on one side, and then the other switch will connect to the access point on the other side, which is fine because one site failure means the access point will still connect to the second site and continue operating, and at that level of resilience. So I'm just giving you an example of how what it is you're supposed to be going towards in your organization and your design. This course will try to get to that depth, but hopefully the group project we could actually get to that way. And look at the bright side, guys. If we get this successfully done in the group project, you can safely say that you could have implemented a redundant failover system setting up there. The access points, we could simulate this as a switch or something like that. We'll work out what to do in the end. A device with 2 interfaces or something like that, right, to simulate that. So this piece, the core, between core and access layer, that's kind of like going to be more LAN stuff and not WAN stuff. Right, I think I would have mentioned some core, the 3-layer topology and 2-layer topology for this. So, but again, WAN is all the way up here. These 3 area, WAN, gateway, that's all the WAN stuff here. So I'm just demonstrating this, telling you where you want to look at. Right, so move this across, back here. Right, so let's continue. You're going to open the packet tracer file. Right, now this packet tracer file also comes with its own instructions. Here, and the website has the instructions as well, but we could follow both this and the website, and we go along like that. Right, so you have some background scenario, and you notice some. So I'll read it out, and we'll see here. Then you have the packet tracer file. Right, these backlinks. The Spanish protocol provides a loop-free redundancy. Now we're done it in LAN. Don't worry about that much in WAN because we're gonna deal with it only in a group project, and we'll have guidance on that one. Right. However, it doesn't provide redundant default gateways for end user devices within the network if a gateway router fails. Right. So look at that. We have an entire enterprise with span and tree, and you've seen that. Those who have done LAN, you've seen that. Yes, it works, but there's a limitation. It's loop-free, but if a link fails, then you have to do a listening, learning, and all those things in order to get that new link up and running. We don't want that. We want a link where it's always up, two sides always up, and this is where you have your load balancing happening. In what do you call you have aggregated switch, and then that each port in that aggregated switch, one port in each, goes down, and that forms a trunk, ether channel trunk. Right, so what I talk about here now is the first hop redundancy protocol. Provides redundant default gateways for any with no additional end user configuration necessary. So you'll see in this situation here, it's R1 and R2 will become your two separate gateways. And if we look at our ubiquity diagram, let me bring it back up. Right, remember I did say the ubiquity would be something of that sort, right? So we bring this diagram and we're looking at saying, hey, where is this looking? You can look at, right? So we have the ISP here. So you see these two internet links here, technically can actually be these two links here, coming out of R2. And our gateway layer would be the R1 and R3. All one layer. So we have kind of like, we have two options here. So we can move the one layer up here and let us collapse into up with the R2, and then we take our gateway layer and that goes between R1 and R3. So gateway layer might actually be, and thinking about it, yeah, that's it. Look at this link between the two. Right? Well, let's see the failover happen from the beginning. Right, look what happened there. So you see there's no link between the two WAN layers, but look what happened, there's a layer between the two gateway layers. So topology wise, that is what they're doing, matching up R1 and R3, which is pretty cool. So we're seeing it right there and then, and this is actually a solution that enterprise use. This is how Unified doing this. You go and try Cisco and see if you get something like this. They're really leading edge in a lot of things in redundancy, and I mean the equipment may not be as good as Cisco in terms of long and last long and all those things, but they cater for it in the price point, and I say, okay, well, let's do the redundancy. So yeah, you have failure, but you're going to continue working. As opposed to Cisco, it's expensive. You can only afford one. It lasts long, but if it fails, everything goes down. Right? Just a little caveat, another caveat, a nice little interesting thing to do. Access points as well. When you set it up, you can do this. You can set up access points where they interleave across a site. So let's say this lab, computer lab, we have two access points really. So what we set it up is that we have each access point will connect to two switches, and that's ideally what you do. So if one switch fails, the access point will continue operating as normal and we're good. But what we do now, we cannot interleave and we swap it. So if let's say we only have only one switch, well, two switches, but we can't do the access point only has one interface coming out, so we can't do redundancy. So what we do is that we take one access point, hook up to one switch in one side of the room, and then adjacent room now we take the next access point and hook it up to the other switch. Right, so you ask yourself, well, what's happening here? The bandwidth is going to be shared and going to go up and you can share, that's fine. But should a switch fail, it doesn't bring down both access points, it brings only one. And the second one may have enough coverage to cover some areas, so your wireless get degraded, but you'll still have wireless in some areas as opposed to just totally out. Right, so that's a plan I will be dealing with South Campus later on. We didn't do that. We actually have everything connected to one switch. So what I'm going to do, I'm going to actually break it up into two switches and then interleave the access points across the classrooms so that we have a redundancy set up. So if a switch fails, the other access point the other half of them will still work. Now I'll check and see if the access points have two NICs in it, because then I will set up redundancy to each switch. So I'm going to be doing something like that. Always good to have green field, so you can always experiment and try something new. Right. So, enough digressing. But to get in a whole background here, by using HSRP, two or more routers can share the same virtual IP MAC address. In this case, right? So, This is a little different. What Ubiquiti solution didn't have that. Ubiquiti actually had two separate interfaces going out. So they technically had a virtual, but they both going out to these two WAN links. But this thing about it, you notice there's two crisscrossing links going out. So basically R2 is like duplicated, and each of them have two crisscrossers. So how R2 is seeing it is that, let's say there's R2 and R4. R2 is seeing one virtual IP, and then R4 is seeing a next virtual IP. And it wouldn't matter which one fails, and that's how that redundancy is set up. So that's where we can actually go to that level too. So again, topology design is really good. I hope you guys are getting a very good take out of the box kind of thing. You can look at this diagram and say, okay, how can I do traffic flow? How can I deal with additional failures? How can I add more devices to increase redundancy? Right, so hosts on the server networks are configured to share the default gateway. They're going to use a shared default gateway. That's fine between these two. That's good. And these two routers now, R1 and R2, then communicate and say, okay, who's going to fail? Well, it's going to fail over, and then the virtual IP is what everybody use. So we're going to configure this, create a virtual gateway, and then that's where everybody uses default gateway. And then we'll test out breaking a device, breaking a link, shutting down a device, reloading, and then see what happens. Right, so first step, trace the path to the web server from PCA. So look at web server here. Go to PCA, which is all the way down here. Right, so I'm following this. You guys could also follow the online procedure. I'm actually going to follow this. Any little caveats and stuff in there or problems, I could just go ahead and explain it out or troubleshoot it. All right. PCA or terminal here, and they said the trace route. .209.165.200.226. Right, the trace route. There it is, going along. Maybe transcript in this thing. Right, nice. So this could have done transcripting. More. Alright, I don't know. Normally I say a transcript, like when it's speaking, it will be able to recognize my text and play it out. That's fine. Right, so trace layout is complete, and when we're looking at it, we're looking at our default gateway is the first IP. It's going out as the first hop, 192.168.1.1. And most likely this may not be configured, so we're going to see if this is really configured or not. It's not supposed to be, but I'm going to investigate and see what's going on, right? 10.1.1.10.1.1.2, right? That's the next IP address. The next default gateway, there's a high chance that'll be the R2 interface on the R2 side, so we'll check that out as well. And then we have the 10.100.100.2, so that's somewhere in the internet section. And then our destination, which is 209.165.200.266. That's a web server, so it kind of makes sense. Each of these hops belong to some group of devices going out there, right? So that's how you should learn how to do the tracing. Right, now we can look at it. 10.112. We could just go back up, check our IP table. Right, that's the interface on R2. Look at that. That's up here. So we're going along with the hop. And then 10.115. It's also an R2. Right, so the next interface. Now, interesting enough, you'll notice one thing. 10.112 and 10.115 technically could be on the same broadcast domain. Well, we'll look at it closely. And that's why you have your subnets. You have to know your subnets. You see a /30 there on each. Those are two separate subnets, because when you break it out, 10.112 belongs to a network range of 0, 1, 2, and the broadcast address will be 513. And then the network address for the next network starts off at 4, 10.114 as the network address, and then 5 would be the first valid IP. Right, so that's what's happening here. I think 10.111, right, that's what I want to know where it went. Right, so 10.111, look at that. It belongs to the 10.1.1.2 network. So obviously that's going to make sense because they need to be in the same broadcast domain in order for packets to actually, for packets to be able to go to the other device, right? So yeah, that's why when you look at through this, you're supposed to look at mixing and matching up and saying, oh, this is this, okay, who's the other device that belongs on this network, right? And you keep going down the line. We saw 10.100, 130, that's Gigo 2. Look at that, dot 1, not looking familiar, but when we did our trace route, what we got? Dot 2, right? So let's look for the 10.100.2. Look at here. And here's the internet gateway. But it makes sense because that is coming from R2 to the internet. So there's actually just one link between them. There's not no fancy stuff in between there. Now they could have switches all in between here in this internet. You can have a bunch of switches because once you do a trace route, every hop along the way, you're supposed to see it listed there. If somebody thinks some routers in between and is hopping along the routers, you're supposed to see those IPs as well. Or you could see like a timeout and a space. If there are switches inside there, you wouldn't see that because they're all just broadcast domain, one to the next, one to the next, and the IP is from just that end of that router. So you wouldn't see that additional switches in there. So sometimes they could hide more stuff in this cloud, but this is how this package is set up. You click on it, I don't think it'll open. Yeah, it's blocked by the auto the activity, so you can't really do anything there. Right. So we did the trace route. So we see the devices, user address table determine device names, which we just did, and we found out who they are, right? So we trace the path to USB from PCB. So now we're going PCB. Terminal, oops, not terminal, command prompt. Right, so trace route 209.165.200.226, and we do this as well. Alright, trace complete. Right, so let's compare this with A, the trace for piece A, and see what's happening here. Right, so we see something. First start off the gateway, 192.168.1.1, and there's a 192.168.1.3, right? Two different devices, so they're not using the same IP, which initially that would have been the initial design. That's good. That means, in my case, we haven't touched HSRP, so I'm actually good. 10.1.1.2, both sides. Right, so 10.1.1.2 is on this interface. So both of these guys actually going to gig 00 most likely. So let's see 10.1.1.2. Right? There's no 10.1.1.5 here. There's only 10.1. So both of them are actually forwarding to just one interface. And which is interesting because, hold on, let me check something here. That's just where. Everything else good, but so why is it 10.1.1.2? Check this. Can I open this up? Yeah, I could. And the block of everything in. Right, 10.1.1.2. So if it's gig 0, how many will this packet coming up here? And going through R1? No way. Right, so that's a weird configuration there. It's just not explaining how it's happening. I'm suspecting it is going 10.1.1 or 10.1.1.9, but it's supposed to do the this interface gig 0.2 here. Can't change anything. It's supposed to be 10.1.1.9 or something. This is show 10.1.1.9 is part of the hub. So this is interesting. Let's see if I can do simulation mode. That's blocked. Alright, okay. We gotta check this out, and next time you guys leave if all you want, or you can actually take the configuration of this and build over a different packet tracer that doesn't have the lockout and continue. But anyhow, right, which device on the PCB to the web server? Now the thing about it, we went through R3 interface, but then somehow R3 was able to go to the gig 00 interface here in R2, which is not supposed to happen. It's supposed to be a gig 01 interface. Right, it's supposed to go to 10.1.1.5. So that's what I find weird, and that's why I wanted to use this packet tracer simulation mode to really check and see where the packet actually going. Because a trace route could only get you that far. And I mean, in reality, that's what it is, right? You can't do much. You know, we could really tell us to drop a wire shark in between the links and then see if you get that ICMP packet flowing through. Right? You could do that, but that's going to be a little difficult in this situation. Right, so you're observing network behavior when R3 becomes unavailable. So you're going to select and delete the delete tool and delete the link between R3 and S3. So this is the doing the link here. Now, two things can happen. I could do. One, we know what's going to happen, right? There's a link going to fail, and you guys can make a guess what you think is going to happen. You think the packet now is going to go through S1 and R1, right? Will it? You can put your bets out there, right? And find out if you can put your bets. I should do a poll in. Can I do a poll? Nope, no poll. Alright, that sucks. Alright. I thought I had access to do this. Me, I can do a poll. Alright. Workout rooms, spotlight. Alright, I'll find out. I think I didn't allow polls in this Zoom sessions, in this Zoom meeting. Alright, anyhow. So I'll leave it up to you to figure out, okay, what do you think is going to happen? So we're going to break this link. So we could come and select R3. Come up here, good. What's the interface? Right, so what is the interface? We gotta see which one, right? We gotta do a shutdown command. And one way to tell is the interface to S3. So it's gig 02. I think it's gig 02. Yeah, let's check it out. Right, so the label's kind of messing up where I could see what's labeled, right? So I can't see. Right, so it's most like gig 00. We're gonna be breaking. Or for that matter, can I open S3? You know what? Right, I'm just going to show you the interface brief, but right, so it's up 3 interfaces. Up 1, 2, 3. Good. So I could play with which one and see which one goes down, right? So let's I'm gonna shut down gig 02 and we're gonna see if that link goes red, right? So I'm touching from the switch end, not the router end. It'll get the same result. Config term 0/ what it is 0/2. Let's do a shot. Right, okay, good. Alright, so from investigation, any questions? Good? Alright, so from investigations, you say, okay, well, how would I know that? Well, you're kind of like investigating using labels, right? So you see gig 01 from switch 3 side, that's done. Most likely, fast Ethernet would connect to your PCs, most likely, not necessarily, but most designs you want to have the higher bandwidth links connecting to the uplinks, and the downlinks should be the lower bandwidth links. And then you have the gig 02 is the next one, which could be either be to the router 3 or it could have been to the switch. Right, so we are process elimination. It's this one I shut down, which is fine. So the next step is that we're going to run our trace route. PCB and see what happens. Alright, so you have to have your bets ready, what you think is going to happen. Will it continue? Will it not give an error? And what? Alright, first request timeout. Let's see if there's another flukes. Next request timeout. Okay, this flukes. This is another flukes. This looks like we're gonna have some problem here. Right, it's gonna have a third timeout and that's it. Okay, so we have a problem. So now it's not working. So of course, I mean, this is the purpose of this lab, demonstrate what happens when a failure happens like this and how we get out to this, right? So I'm gonna continue this tracer. I'm gonna go for a while, to about 30 or 15 or 30. Right, so compare with what was step 2, what were the results? So we get more timing out, and I will keep going, right? Right, so you can click the connections and locate and see the copper tracer icon in pod. They said that, I don't know. Right, click the connection icon lower left corner. Copper straight through. So this guy. Click on S3. You get Ethernet 02. I don't see. Yep, no, that's used up. Oh, sorry. We used the delete 2. I shut it down. I went way ahead. All right, I went and do something else. Okay, let's undo our shutdown, right? Interface. No shot, right? So look at me. I bring it back up. Make life easy. Okay. So they said to use the delete tool. So yeah, then you have to do it. Let's see what happens. So we're literally breaking the link here. And it's going to have the same result, right? Because timeout, traffic not going to flow. So the question you're thinking, hey, if traffic is going to flow through here, we're hoping, and well, that's not what's happening here. So they said, okay, just go back and do over the connections and reconnect, right? Right, straight through, go to this and then select gig 0. So we're looking at gig 02, which is what we shut down the switch to gig 0 on the router. Straight through. Look at there, because the DLD link is now available, and now we're going to gig 0. Let's back up. See, after both are green, ping the website, the ping should be successful, right? So the green, you'll notice the little orange there and a green triangle and an orange circle. So that's the switch is doing its span tree stuff, learning and listening and learning. But what I want to do is let this tracer continue running. I want to see what happens. This tracer will start to work afterwards. Okay, so it did some fancy stuff. Look at it, complete, but no, let's do it over. Alright, so remember, so tracer road, it's a long way it'll do each route and then try to do an ICMP thing, kind of thing. Right, there it is, back up and running. So that link, breaking that link actually did affect the performance. So now we have to find out, well, how we could sort this out, right? So let's on to the next part. So we're going to configure HSRP active and standby routers. We're going to configure HSRP on router 1, protocol version, and standby IP and all these things. So let's go into router 1 and let's start this. interface gig 02. Before we continue, let's take a look who's gig 02. It's not telling me anything. Alright, just let me scroll up to the top. Right, 10.1119/30. Right, so you notice a few things. This table has it, but you have to see who's matching up these /9. So who's matched up with /9 could either be if you work it out, could be either possibly an 8, may not be an 8, it could be a 10. Right, so if you look here, it's R3 gig 02. Right, so this is basically configuring the standbys across this link here between R1 and R3. Right, that's what we're doing. So that's what we follow in the lab, and we actually going to explain which parts are happening here. Just a thing to let you guys know is this piece of this is going to come in the lab exam, right? So make sure you guys know how to do this anyway. Right, next step, let's continue. Right, we select the interface. Right, and then we select so we're on the interface and we do a standby. So let's go into there. Right, so we know we're on the right track when we do standby, type space and question mark, and we see some options come up. That means it's available on that interface, right? And we do a version is there, space, question mark, and look what happened in version numbers. We're going to do version 2. Right, so you configure the IP address of the virtual gateway. Right, replaces the physical on the router as configure the host. Right, multiple instances can be configured on a router, different interfaces and stuff. Specify the group number and the virtual IP. So you can actually have more than one virtual IP, which is good because then you can route to different things as well. Right, so the standby one is the let's say the grouping, that instance. Right, so you can do standby 2, and we make sure if you want to make sure they share the same virtual IP. That same standby number is used. So continuing, standby, right, level range, right, group member up here. So we're going to do 1. IP, virtual address, right? 2.168.1.254. Right, designated active router, standby 1, priority 150. Right, range of value 0 to 5, 150 is pretty high. Right, standby active. And I have something called preempt to resume the role. So if it became down and came back up, it's going to come back up as the primary router. Standby 1, preempt. Interesting enough, from this list, then we kind of like did 1, 2, 3. We even did timeless track, but we did half of this stuff in commands already. Right, so it's look how easy it is to kind of learn all this. Just going through these commands, you kind of do all the parameters there. Right, now we're going to configure it on R3, so we did it on R1. The repeat steps 1, B, and C above. So it's only just 2 steps, right? B and C. Basically, is the standby version. A as well, yeah, select the interface, right? Right, so we'll have to make sure we get it right interface. Let me see. R1 is 0, 1 gig 01 we did. No, we did 02. I just want to see where 02 leading up to. 10190. So there's a chance that for R3 it will be the gig 02 as well. Double check here. Oh no, gig 01. Alright, hold on. Now just verifying something. Gig 01. Okay, I think I configured the wrong interface in this. Right, okay, wrong one. Right, so I had to be careful what I did. I went to the wrong interface. So hope you guys following me and not following me, right? So I made a mistake here where this interface should not have it, because when I realized it's 1.254, it's supposed to kind of be in the same subnet as this one. So that's a /24, that's a /30. So that's one thing I realized something was off. And two, yeah, the communication, when I look at R3 now and it's saying, hey, you know, you have to do the others, I knew something was off when I was looking at R3. So, question is, how do I undo all of this instead of reloading the router? So I'm going to actually go back into this interface and I'm going to do no commands for all of these. I'm going to copy this first. Run notepad, paste it up, I'm going to run some no commands, right? But I'm going to do a no command in reverse order. Right, so first things first, I'm going to start no with this guy. This part here, once I finish this, is supposed to be end of it. So I'm undoing everything in this order. Okay, so I'm going to copy this guy. Configure this right. Paste this. Right. I already interface right. So now I just copy this and undo these things. Alright, one in. Second one, third one, fourth one, right. This is go 2, done. Clean out the config, right? So this is a nice little tip if you think you make changes and you don't want to reload the device, and especially when you don't want to reload your device. Check and see what was made in the running config, and then you work out the undo. Now, why I did it in the reverse order of the undo is because now it could work. Sometimes if you do a no standby version 2, it might clear that, and then all the other commands can come out. But sometimes the way our design is that they can end up having or fund, as they call it, where these standby priority IP and stuff could end up being off and still there and could cause unexpected results or something else could happen, right? So that's why I undo it from the way up, because you know you can have this or not. That's not a problem. You can take that out. That's still going to work. All this, you can take this out, and then you leave this for last and you take it out. Okay, good. So let's fix this up. We're going to back interface, right? Gig 01. All right. Let me just save this. So I wouldn't have to make a mistake. If it crashes, at least I'll have I'm not going to go back to this file. Right, so we're still in R1. Let me undo all of this. Good. Sure. Good, good. Right. Standby. Right, other stuff. Version 2. My standby 1 IP. One at 254. That's good. Standby 1 priority. Value here 150. See what else we have there. Nothing else right now. It's good. And a preempt, right? Right, I think that's something like that. Good. Now we go into R3. So let's do an sure run and make sure we're on the right track now, right? So made our changes on gig 01. Right? This is where we want it here. Right? And it's matching up the, look at this, 16254 and 192.168.1.1, and both are /24. So you're thinking, hey, how are you getting two IPs on this, right? It created a virtual IP address using this mechanism. So we're going to start using this soon. But what's happening here, you're going to see it's using this IP. Right, now into 3. Of course, we're not going to do 0. It's 002. It's just to make sure we're in the right one. We look at the 192.168 IP address for 3. So if we're not so sure, right? Let's go where am I? We'll do 0. Well, let's see if we make sure, right? Do show run. I can see. So while I'm along configuring along the way, I verify it. So 192.168.1.3/24, which is what the PCB was trying to ping, and when we shut down the link, it couldn't get that. The gateway is gone. It was specifically set for this, right? But 00 is what we want to do, right? So we're going to set this. We select the interface. Now we just repeat the steps. Where it is? 1B and 1C. Right. Well, they should have done 1E, but they couldn't repeat 1A because there's a different interface number, gig 00. So they couldn't say repeat that. But the problem is that they should have specified, and that's why I kind of do my labs as well. I set up goes straight down to the level of detail. Standby IP version 2, and we're not doing anything else after that. Everything else is priority and preempt, which we don't want. Right? So now we're going to verify the HSRP configuration. So basically in R1, do a show standby. Verify the values in the rows. Right? So let's come here. Right, STA, startup config, we don't want that, just type N, and you got standby, you can tab it and it should fill it. Nothing else here, we can check this out, right? Right, so show standby, and they show you some example output here. right? Group version 2 active, 8 state changes in this case. Why it happened is because we end up bringing it down up on those things, right? Virtual IP address, active virtual MAC, this is local MAC address. Right, so you have the hello timers, check to see if the neighbor is alive. Preemption enabled active router is local, standby router is 192.1.3, so 103 is the standby router, the other one. Priority configured, priority 150 configured is 150. I didn't have a group name, default name. Let's do to R3, show standby and see what it's saying. Right. Compare these two. Right, status standby. 5 state changes versus this 8 here. We only did this once, config, didn't have to do much. Virtual IP address, 191.1.254. So you see something, 2 things are the same here. Active virtual MAC, F001, local virtual MAC, F01, right? Default. Anything else? Active router is telling you who is the active router. So you can see something here. The active router here is local, which is itself, and then the active router, the other this one is saying it's 1 at 1. Standby router is local, that's itself, while the other one is saying standby router is a remote device. Look what is happening here. Priority 100. And the default is 100. So this is what we didn't configure. Remember the 2 things we didn't configure: priority and preempt. So priority is right, preemption disabled, you can see here, while preemption is enabled here. So priority is 100, default is 100. So when you don't set any priority, default is 100. Now if you set something where you have the priorities, no priority is set, then they might use the MAC address values to determine who is going to be the or the IP address to determine who's going to be the actual primary device. Right, now you can see its priority is 150, configure is 150, means that we manually set this. Right, so we did this. Answer for which router is the active router? Well, we just explained that. What is the MAC address of the virtual IP? We saw that at the F001. What is the address and priority of the standby router, right? The 1.3 and the priority is 100. Use the show standby brief to show the status as well. A brief is actually good because it shows brief, but can I give you more information in a sense? Careful how I am. It's very good. She gets stable too much. I reckon I get a better tripod. There's not even a tripod, it's a monopole. Anyhow, let me just move this. I just resizing this so it looks neater. Alright, work with that. Good. Right, so it's a nice table because it gives you comparison here. So you have group 1 priority. P indicates configured to preempt, yes, while the other one is not, it's empty. Status standby while the other one is active, and then the active IP is local, while this one is it's telling you it's remote person, so it matches. Then the standby is the other one, and then the standby on the other side is local, and then virtual IP. Right, so this is good. Right, now we're going to change the default gateway addresses for PCA, PCC, S1, and S3. Now it's asking which address to use. Well, we got to use the one that we just configured, the virtual address. That's the idea, because we want everybody to use a single one. And as we go through each one, you're going to see some interesting things going on there, right? Well, let's say PCA, PCC. Where is PCC? Where's PCC? A, B, and where's C? There's no C, there's B. There's a typo, right? That's why I'm running through this lab. If you were doing this and you find this problem, then you could always, questions and stuff like that. Okay, let's go to A first. IP configuration, allow me to do it. Right? What is 1.254? This is IP. You know what we should really do? As much as I would like to configure this, we should really it's configured there, but let me just ping this thing just to make sure, right? It's pingable, so therefore I can use it. I'm going to go to the PCB and I'm going to do the same thing, but I'm going to I'm going to configure it. I'm going to actually ping it. Right, so it's pingable means that I can actually use it. Right, you notice one thing, it was 1.1 in PCA, and the PCB is the gateway is 1.3. So remember when earlier on we shut down the delete the link between the switch and that gateway interface? Right, PCB does not know where to go after that. It only knows how to find its default gateway is 1.3. Can't find it, so it's just going to get timeout. Can't get out anywhere else. We're going to fix that. We're going to use this virtual IP now, where it's going to use 1.254. Alright, just close it off, open back up to make sure it's saved right. It's there. Not a problem here. And we can do a trace route. Nothing new in trace route, that's fine. This has to do for the switches as well. So switches are a little different because there's no point and click to the stuff, right? Enable. So the one way I'm going to show you how to do this. That's why I like about Shore and stuff. Look at this. IP default gateway 192.168.1.1, while the other switch will most likely be, this is switch 1. Let's open up switch 3. And we could do a show run and we'll see what's happening here as well, right? Right, IP default gateway 1.3 in this case, while the other one is 1.1. So we're just going to go config T and do IP default gateway and change it to the new one, right? Right, 192.168.1.254. Right, anything else after that? Right, nothing. So we're done with this. Anything after that? No. Alright. And then let's do the same thing, right? Default gateway change, default gateway change. Interesting enough, we could ask for, can this switch ping this IP? Right, yes it can, because of the, right, there you go, success, right? S3 can do the same thing. Why? Because with VLAN, so this is more LAN tech stuff, where they created a default VLAN for switches and placed an IP, set an IP address on that VLAN for that switch. So that way, and the thing about it is that default VLAN is VLAN 1 as the port. Let me check. Remember, there's no trunking, and there's not the default VLAN is VLAN 1. So if I do a show VLAN, for those who are doing when it was about VLANs, all ports are on the default VLAN 1. So if you select the VLAN 1 and set an IP address, that's all that's going to be broadcast on that default. Means your PCs can see it, the routers can see it, and then the switches can see it and going out. I didn't do too much of that detail in the LAN course, but you can actually set a different VLAN number, ID, set up a trunk port, and that VLAN will be trunked across to somewhere else, and that can actually be accessible somewhere else. So you can actually ping that IP and connect to that switch somewhere on another switch. But that's not what this course is about. Right, so we at 7:01, we did these changes. Right, ping A, C, and B to the web server. Pings are successful, yes. And now we're going to do the breaking of the link. and see what happens. But we're going to take a break first, and we're going to resume at part 3. Right, we're going to resume at 7:11. Alright guys, see you in a bit. Alright, so let's resume. So now we're going to observe, we're going to do some checks here. So that's what we're doing. Verify the new settings. Issue a ping from both PCA and PCC to the web server. And then we ask if the ping is successful. Well, in most cases it would be successful because we didn't, the trace route worked, and then we just do the ping as well. So that's what we're going to do. PCA, PCB. Alright, so let's do the trace route. And then we just modify this trace route command, just take this command out and put ping. Right, no problems, right? Everything's working now. Alright, so we're pretty much good here. Right, things are make the active route. Right, so what we're going to do, we're going to make the active route unavailable. Open a command prompt, enter the trace route. Does the path differ from the path before the HSRP was configured? So we did the trace routes already. Right, so it's using the 1.1 as the first hop. Right, so, and this is the interesting thing. We did one or 254 is our default gateway. So we're using this, and somehow our first hop is went up too high? Yeah. Our first hop is 1.1. Why 1.1? 1.1 is the primary, right? So it's the that. So ideally, once we do a failure of devices, that 1.1 is going to change to 1.3. That's because of it's going to the default, the virtual IP, and the virtual IP is sending it to this to the actual physical IP, and then outgoing. Right, so we're going to break and delete the cable that connects R1 to S1. But before we do that, right, so part before the HSRP. So the part before, let me go back to PCB. When we scroll, hopefully have enough history. Right, 1.3 was where it was going before, but now we set it to 254 and it's going to 1.1. What we're going to do, interesting enough, we're going to do a ping operation. I think I could do a none. See if it makes anything. Right. I'm going to do a ping operation and tell it to ping 10,000 times continuously. And we're going to actually, I'm going to do the same thing. 10,000 times on PCA as well. Getting response, that's fine. So now we're going to actually do some breaking the links between R1 and S1. Right, that's what it's saying. We'll take a delete. Where you break it? Come on, cut. Right, there we go. Some timing out here. Let's see some output from router 1. See some output from router 2. I mean, sorry, router 3, sorry. Link went it down, standby went to active. Just waiting a bit here. Alright. And there you go here. Alright, so this is the HSRP doing what we want. And you see the router state has changed. This is OSPF stuff, but that's LAN, more LAN stuff, so don't worry about that. But the state changed from standby to active. That's what happened. The communication when it lost communication. And our ping operations continue as normal. But it had a timeout, right? So it didn't it wasn't as neat as we'd like it to be. So I mean that's the best you could get. I think you could get more better performance depending on the technology you're using. But for those who this is for, let's say you're playing online games and this happens and a link breaks. Would that game would you get lag and then you time out and get quit, or will the game continue? Right? It depends on how good resilience the game engine is set up in terms of communication. So it sticks, and after it gets communication, continue going. Right? I think in my situation, if I had my WAN load balancing with Ubiquiti, while I'm playing, I could actually pull a cable. The game might stick in load balance and it'll continue going. It's pretty, because it's doing active balancing, so it doesn't have to wait. So it is maybe 1 or 2 second wait. That's ping timeout waits, and that's it, and then the game will continue going. So that's what I like about it. Same with YouTube streaming. I really haven't tested it out. I think I did, where YouTube stream on one link and then I pull the cable on the other one, on the main uplink, and then it will then switch over to the other YouTube supposed to continue. YouTube has a kind of like a 10-second or 20-second buffer time to allow that if your connection is dropped and it for a while and then it continues streaming after less than a few seconds, it will continue to stream. Right, so it has ability. So we're going there. So what we're going to do, right, immediately and then execute the trace route. But I just did the ping, so they said immediately. But I'm just going to go back and do the trace route now. That's PCA, and we're going to do that in PCB. Oh, this is a weird number here. Let's do this over. This may be a negative value, and that's why it ended up becoming so large. Right, I sign integer business. Alright, so look what's happening here. The default gateway has changed to 1.3, which is the next router, even though the virtual is set as 1.254, and that's how our HSRP will operate. Sometimes the gateway, load balancing, and VRP, these are the protocols. If you break one, they still use that virtual IP as the trace route going out. So it all depends. You gotta try it out. Right. So this is what you're seeing here. Right. To get trace the full part, we got the full part. The front, the process should take over. Takes over time. When the process is complete, the standby becomes active and is used. Now, before I finish that, before I reconnect. Right, what I want to do, I want to go in each router and run the same commands that we ran before about standby, right? Now, some of these things, look at this. Standby is not recognized. The reason being is because we are in the user exec mode. No, not in user exec. Yeah, user exec mode, which is like regular mode, and then you have to go into privilege exec admin. So if you do a show stan, Steve A1, then it's seeing it, right? Show standby, and we're getting this. Let's go to the other router 3. Right, so you see some things there. State in it, the fitness is down on the other side, which we brought down. This case status active, 68 inches, nothing happening here, state changes. Virtual IP address 1.254 didn't change. MAC remains the same, nothing changed. Hello timer is there. Preamp is enabled, disabled. So all these other things remain the same. Active router is local, which is this one, and active router is unknown. Standby is unknown because of the communication, the link communication, all those things, right? So it lost that communication. Right, so alright, so what is this summary? I think there was another command here. Brief. Alright, we're just doing brief just to see what's happening here. Right, active, unknown, standby is unknown, but the active is local and its own standby is unknown. Right, because it's itself is a standby. There's no other router sort of standby. You can do a third router or more, and those can end up being standbys as well. Right, so you're going to reconnect the cable. Right, so I just broke a link and I try to remember what it is I trying to connect back, right? So for the S1, well, I can't remember what it was. Let me just go back to the diagram. And this is what you need diagrams for, right? If you don't record it. Nothing here is showing you the connection to the switch. Right, VLAN 1, but there's no interfaces. So what's my interface connection labeled between R1 and S1? Yeah, we know for sure 192.1.1 has gig 01, but what is the port on the switch that we need to connect to on S1? Right, so it's not documented here. And this is where you have to make sure you document your stuff properly so that you know what's happening. Right? We'll have to go back to the diagram, and where that diagram is, we had to end up, because we make changes, right? So you had to go back into a diagram that we had opened before. So we had to go back to, let's say, the web page or website that we had this just to go back to. So I'm just going to bring this up here and see if this has the, all right. So this is not even helping. Go back to PowerPoint now. Right, look at this. Gig 0 and 02. So diagrams are important with your interface. So when you're doing the assignment 1, yeah, I expect labels, right? Group project, same thing. For the lab exam, not a problem. You don't have to label, you just have to get the thing working. Alright, troubleshooting. But for this, you need the labels. So gig 01 to gig 02. So let's verify that. Let's go back to our stuff here. Gig 01 is correct. And we're going to gig 02 of switch 1. So there's nothing here showing that it's gig 02 of switch 1. Right? That's why you rely on your diagram. Right? It's connections, straight through, gig 01 to gig 02. Now you might click on it, obviously see that, but it could have been any of these that could have worked as well. Right? So the switch is coming up. You'll notice nothing, the state hasn't changed here. No. Right. Let me go R1. R1 way down here now. Okay, went already. Okay. Right, so something's happening here. Let me just go back PCA. Running some trace route, something's changed happening. Right, it happened because all the interface is green. Right, some negatives here, but look at this, back to 1.1 is the trace route immediately. Standby brief. Right, so this one from active, so you can see it went from standby to active, so there was some communication here, standby, and standby to active, while the other one went from speak to standby. We do the brief, so the active is now back up, local is this, standby itself is local, while the active on the other side, the active one is now back to active, is the local one, and standby is 1.3. PCB, we do a trace route. Now, some people say, well, why taking so long even though the MAC address is virtual and it's working? Where the other switch 3, learned that MAC address would be in a different port. So sometimes it's saying, okay, I can't find back in this port, it's in the other port, so it has to do over a rebroadcast, right? Let me just go to the switch and we'll do a quick check. Right, it's supposed to do the virtual MAC. I don't see the virtual MAC here. Right, let's make sure we do it again. I do the trick out to force some MAC address to learn. Right, the only thing is, in this example here, right, so we have to go back to our status here. So they use F001 as examples in MAC, but we can't use that. We have to use, go back R1 and R3. Right, we have to know what's its MAC address, virtual MAC address was done. Oh, they use that 001, alright. Right, ideally I was hoping that the switch would show it, it didn't. There's no F001 here. So gig 01, you'll have to do the show interface. Right, it'll be 9402. Let's see if that's the case. Right, 9402. Alright. Alright, so the switch actually, both switches, so that value is going to change. That 9402 is going to stay there, that's correct. But the traffic to get to the, like, let's say when it goes to the standby becomes active, that will change. I didn't go into that, delve into that details, but that's what ended up happening. So you guys could check that out if you want and see if the MAC address for R3, let's see, R3 comes up. Where are we? Right. 000. Right, MAC is right. 8B01. Right, so you see 8B01 here. After a while, this should disappear, independent, because it's not the primary. So we do a show MAC address table. You can see that I could do a clear MAC address and let it regenerate, and it should not the 8B01 wouldn't be there anymore. And when we do the failover, it'll reload and 8B01 come on. Even though 9402 will still be there, it'll eventually just get aged out. Right, so that more or less completes it because we're done here. We did the trace, what part it reached the web. If the preamp was not configured on R1, would the results have been the same? So of course preamp would say, okay, would it go back to R1 because it changed, which is 1.1, or will it stay at the 1.3? Right, because the preamp was set, it was always supposed to go back to R.1. So you could experiment and actually say, hey, let's do the sorry, without the preamp, it should go to the 1.3, which is in router 3, and that should end up being the gateway that will end up default for everybody. Right, so I think that's it. So yeah, we've been a short lab, so I'm not going to go too long and do other things. We'll wrap up here. Right, so all this other configurations here. This is the final solution. Well, nothing really changed. We just bring back up the link, and that's it. Right, so that's the end of this lab. Alright guys, thank you very much. You guys gotta go home early. Alright, any questions, send me an email, put it up on the forum. For the assignment, yeah, some of you guys asking me chat and stuff, you're having problems with your GNS3. I put a steps here. Give me SOP. I have gave you an SOP to follow. standard operating procedure, right? So you need to do some diagnostics first. You're saying that you can't get just dynamics. Go and check out and see what the problem is online. Some people say, okay, uninstall GNS3, reinstall GNS3. I had a case, and that's what happened. We ended up doing a one-on-one with somebody last week, and the problem was to reinstall an older version of GNS3, 2.2.52, because the latest is 2.2.56 and was causing trouble. Right? So that was one solution, but please post it on the forum so that we can then go through that process and others can answer, and use the WhatsApp chat, right? So I can help out. I hope you guys get into the WhatsApp chat to help one another. Alright guys, that's great. See you guys on Wednesday, right, for class. It might be a short class because we're talking about the same thing, HSRP, and you could enjoy it kind of after. Alright, okay, bye everybody. Share, mute, no video, end.